Imagine an AI that can research faster than any human, automate your business tasks, or even create art, all by learning on its own. In 2025, AI agents are doing exactly that, and their secret sauce is how they learn. But the question is, how do these agents learn to do such amazing things? So what does it mean for an AI agent to learn? In simple terms, learning is how an AI improves its ability to perform tasks by analyzing data and adjusting its behavior. It's like how you get better at a game the more you play, but for AI, it's all about data. There are three main ways AI agents learn: supervised learning, unsupervised learning, and reinforcement learning. We're going to break each one down with analogies you'll relate to, then dive into how they power some of the coolest AI tools in 2025. Let's start with supervised learning, the most common way AI agents learn. Imagine you're teaching a child to recognize fruits. You show them an apple and say, "This is an apple," then a banana, and say, "This is a banana." After seeing lots of examples, the child can look at a new fruit and say, "That's an apple." Supervised learning works the same way. The AI is given a data set where each piece of data is labeled with the correct answer, and it learns to make predictions based on those examples. Here's how it works in detail. The AI is fed input data, like an image of a fruit, and the correct output, like the label, apple. It makes a prediction, and if it's wrong, it adjusts its internal settings to get closer to the right answer. Over time, after seeing thousands or millions of examples, it gets really good at predicting. This process is powered by something called a neural network, which we'll talk about later. In 2025, supervised learning is used in tools like DALL-E 3, an AI that creates images from text descriptions. For example, if you type this prompt, a mini-map diorama of a cafe adorned with indoor plants, with some detailed information like wooden beams and a cold brew station, etc., DALL-E 3 generates a stunning image. How? It was trained on millions of image-text pairs, like pictures labeled with descriptions. During training, it learned to match text inputs to visual outputs, so that it can create new images based on what it learned. This is huge for creative industries, where businesses use DALL-E 3 to design ads, logos, or even virtual art for marketing campaigns. Next up is unsupervised learning. Unsupervised learning is a bit like organizing a messy room without instructions. Imagine you're sorting a pile of clothes. You might group all the red shirts together and the blue socks in another pile just by noticing similarities. You're finding patterns without being told what to look for. That's what unsupervised learning does. It analyzes data without labels and groups it based on patterns or similarities. In unsupervised learning, the AI looks at a data set and tries to find structure in it. For example, it might group customers based on their buying habits or identify unusual patterns in financial transactions. The AI doesn't know what the groups mean. It just finds them. This is done using techniques like clustering, where similar items are grouped together, or dimensionality reduction, which simplifies complex data while keeping the important bits. A great example in 2025 is Salesforce Agentforce, a platform that builds AI agents for business tasks like customer service or marketing. Agentforce uses unsupervised learning to analyze customer data and find hidden patterns, like grouping customers who buy similar products. This helps businesses create targeted campaigns without manually sorting through data. For instance, marketers can save time on generating campaign briefs, targeting audience segments, creating content, and even building customer journeys and flow. And because Agentforce never sleeps, it will continually analyze performance against KPIs and proactively recommend improvements. Unsupervised learning makes this fast and automatic. Finally, we have reinforcement learning, which is all about learning through trial and error. Think of training a dog to sit. When it sits on command, you give it a treat, and it learns to do it again. If it doesn't, you might say no and it tries something else. Over time, the dog figures out what gets the most treats. Reinforcement learning works the same way. The AI takes actions, gets feedback, rewards or penalties, and learns to maximize the rewards. In reinforcement learning, the AI is like an agent in a game. It explores an environment, like a virtual world or a business scenario, makes decisions, and sees what happens. If the outcome is good, it gets a reward, like points in a game. If it's bad, it might get a penalty. The AI uses this feedback to adjust its strategy, trying to get the highest reward possible. This is perfect for tasks where there's no single right answer, just better or worse choices. In 2025, Deep Research by OpenAI uses reinforcement learning to become a super smart research assistant. It browses the web, reads articles, and compiles reports for businesses, like a marketing company studying the retail industry. Deep Research learns by trial and error. When it finds relevant information, it gets a reward, and when it misses the mark, it adjusts its approach. Over time, it gets better at finding the most useful sources, saving researchers hours of work. It's like having a tireless intern who gets smarter every day. Now, let's go deeper into how these learning methods actually work. At the core of most AI agents is a neural network, which is like a simplified version of the human brain. Picture a network of interconnected nodes, organized in layers. Each node processes a bit of information, and the connections between them have weights that determine how much influence one node has on another. Here's how it works. The input data, like an image or a text description, enters the first layer. Each node does a small calculation, passes the result to the next layer, and so on, until the final layer produces an output, like a prediction or decision. During learning, the AI adjusts the weights of these connections to make the output more accurate. In supervised learning, the AI compares its output to the correct answer and tweaks the weights to reduce the error. It's like fine-tuning a recipe until the dish tastes just right. In unsupervised learning, the AI adjusts weights to find patterns, like grouping similar data points together. In reinforcement learning, the weights are updated based on rewards, so the AI learns which actions lead to the best outcomes. Neural networks can have dozens or even hundreds of layers, which is why we call it deep learning. These deep networks are what make modern AI so powerful, allowing agents to handle complex tasks like generating images or automating business processes. But they need lots of data and computing power to train, which is why companies like OpenAI and Salesforce invest heavily in building them. That's it for today's deep dive into how AI agents learn. If you loved this, give us a like, subscribe, and let us know in the comments. What's one way AI learning could impact your life or work?